Hey there, welcome to 4D BIM for Schedulers. In this short demonstration, we'll show you how Vico Office is not a glueware application. It doesn't just stick a 3D model to a schedule and create a pretty movie. What we'll show you is how it combines 3D models, uses patented location management, leverages location-based quantities, creates more accurate schedules and optimizes those, provides essential production control for our projects, and creates pretty 4D simulations. I hope you enjoy it. Let's check out bringing in 3D models. This is a Revit model. Simply hit Publish from the Vico add-on in the ribbon, and it will show you the available projects in the project server. Publish, and when your publish is complete, the model will appear in Vico's document register. Let's also publish the superstructure. Vico Office supports many different file formats, including Revit, ArchiCAD, Tekla, IFC, AutoCAD MEP, AutoCAD Architecture, SketchUp, CAD Duct, and many more. Here we'll see an architectural model being published from ArchiCAD as well. Importantly, Vico Office stores a full version history of the 3D models too. If we make changes to this Revit model, we can add some slab penetrations, modify some of the pile caps, and we can republish it as a new version of the 3D model. The new version will be flagged with a red square in our document register. We can then review the models and simply drag and drop to see the latest version. Let's check out project location management. Vico Office uses a patented non-destructive element splitting technology. Here we see floor locations that could split, for example, columns that would pass through multiple floors. We see the floor isolated and understand what is included in that scope. Let's switch to the floor plan view for the foundations and add some zones for the concrete pours. We add polylines using the snapping features and leader lines. We'll divide the foundations into 4 pour zones. These 4 new pour zones will virtually split the elements in the foundation. It will also recalculate the quantities for each location. We see the 4 zones and the construction caliber quantities now divided into those zones. Quantities per location are the key to integrated virtual construction management. Vico's scheduling solution adds more power to the basic CPM scheduling method. Here we can see project locations on the left and time along the top. Lines then represent the flow of each trade as they move through the project locations. We can clearly see where people should be working and also where people are not working, the poorly utilized locations and the starts and stops. Schedule Planner can force continuous work for trades, and then after this, representing the waste, we can balance the resources so that we're using the optimum number of people on each trade. Buffers are then added between these trades to protect against any uncertainty in the workflow and make sure that the schedule is achievable. Here in the software we see a piling task added, which shows in the location-based view and also in the Gantt chart view on the right. By dragging and dropping from the estimate, we're going to leverage the integrated workflow and exploit any of the work already done by the estimator. The task is then loaded with quantities, costs and resources for each location where there is work. We see more accurate scheduling because of the calculation for each duration in every location. Because of the varying quantity of work, we have a different duration. We can add more tasks, drag and drop, and define task drivers by adding the hours per unit or units per hour. This method results in task durations calculated for each location with the assumptions being made explicit and available for update. We can also have a many-to-one relationship, and if the estimator has already provided resources, we can synchronize using a one-to-one relationship between the estimate and the schedule. The next step is to define trade logic, and this can be done in any view, but quickly creating it in the network view and letting the layers of location-based logic automate the rest is a pretty fun way to build a schedule. Here we see how all of the trade links and logical dependencies are created automatically in the Gantt chart. We can now use the flowline view and drag the tops of the lines to see how many resources we would require in order to optimize around any of the bottleneck trades. 4 piling rigs here would be required in order to achieve the pace, 2 rebar crews, and so on. We can allow for some work like the concreting activity to be discontinuous, and we're dragging and optimizing the other trades around. We can highlight the critical path and then define the areas where we need to add buffers to protect against any uncertainty in the field. As changes are made in any of the views, all of the other views are kept in sync. Instantly, we can review the 4D simulation to check for any schedule busts. It must be noticed that this is not a new method. It was in fact used on the Empire State Building with amazing results. It was a 102-story building in 18 months, and they used the location-based management principles to plan for continuous and aligned work with the emphasis on controlling the work. They used actual quantities per location to plan. They managed by production rather than just by the end date. And they were trying really to reduce the risk of that cascading delay that we'll see later. This method was specifically designed for construction. We're able to highlight planned work by location, identify wasted opportunities, the bottlenecks and inefficiencies, the starts and stops. We're then able to optimize the plan and start with the right number of resources on the right date. We ensure continuous flow. And adding BIM and lean principles to this method just takes it a step further. Most traditional scheduling tools focus on the planning and the recording of data and less on the controlling processes required to actually execute to that plan. Using Schedule Planner and Production Controller with the BIM inputs, we're able to up our game. As we've seen, we prepare a more optimum plan by leveraging location-based quantities, productivity data, cost and resources to drive our schedules. We also use pull planning processes to implement realistic look-ahead plans and achieve commitment to the plan. Analysis of actual productivity data provides us forecasting and warnings of any potential clashes in the field, and we use these forecasts and the alarms to inform site meetings, implement mitigation measures, and really control the plan. We then complete that learning loop to provide better starting data and improve our next plan. In the tool, we use a simple matrix of locations and tasks to check off what's been complete. This progress is shown as a dotted line in the flow line against the solid target lines. Green squares show complete, blue on time, yellow is behind, and red is late starting. The forecast is then shown as a dashed line in the flow line view. Alarm warnings with red dots forecast likely clashes and the potential of a cascading delay is highlighted. We can see that the change of one drywalling crew is going to correct the forecast. Very simply, we had one crew. Changing to 2 crews will bring the drywalling back on track and correct the problem. In the software, we can step through time to today's report date by using the history mode. We see the dotted line showing historical progress for the piling activity. For the form pile caps task, we can enter progress by clicking on the matrix and choosing either simple start and end dates for that location, or by adding progress per day and indicating whether we were or were not working on some of the days. This productivity data will then be used in the forecast to show the impact of not changing anything over the next few weeks. We see the impact is a few weeks out due to this deviation in zone 3, but if we add actual resources used over the last few days and refresh the forecast, we can see the impact will actually be next week in zone 2. We can then edit the control plan to isolate the affected trades and evaluate what-if scenarios. We can see how changing working methods, working hours, overtime, or resources can mitigate the problems. In this example, we found that 4 crews were required in order to ensure that the trades did not clash. Through the implementation of these planning and controlling processes, our customers are able to make better informed decisions and clearly share scientifically driven and evidence-based data with project partners. To recap, we collect progress using the control matrix. Actual productivity and the remaining quantities of work will calculate a forecast. The forecasts are reviewed in the weekly subcontractor meetings. Control actions are discussed to mitigate potential problems and are used to make daily and weekly commitments. PPC metrics and root cause analysis are used to support a learning culture and help ensure teams work towards making more reliable promises. The social sharing process on site is done via the production wall. This is a visual display of progress, commitments, and performance. In this short introduction, we've seen the combination of 3D models, how we add locations to virtually split model elements and recalculate quantities per location, how we quantity, cost, and resource load our schedules, how we improve on the CPM algorithms and incorporate a location-based management philosophy in order to optimize for continuous flow and contain less waste in our schedules, and also how we use actual progress and resources combined with remaining quantities to forecast trade flow and highlight any potential impacts as early as possible. You can see more comprehensive project examples in Fridays with Vico sessions on our website and on the YouTube channel. Please get in touch for more information about Vico Office.